Bismillahirrahmanirrahim. Welcome back to this topic, which is measure of the central tendency. In the last part, we spoke about the measure of central tendency, which is the mean, median, and the mode for any group data. And we said that the mean is the sum of all the values divided by the number of the values, while the median is the midpoint of the data array, in which that we need to arrange the data ascending or descending, then choose the middle value. And the mode is the value that occurs the most often in the data set. In this part, we are going to speak about the grouped data. And we are going to find the mean, mode, and the median. Mean for the group data, median using formula or the graph, and also the mode, same thing, mode and median using the formula or the graph or the frequency distribution. Let's start by the mean for grouped data. In this example, we are given the frequency distribution of the scores of students in statistics class, and we need to find the mean and the mode. For the mean, we are going to use this formula. X bar equal to sigma of f multiplied by the midpoint of the classes divided by n. What is different about this one is that we need to find the midpoint, then we multiply and find the sigma. In the n group data, it was x bar equal to sigma of the values divided by n. Sigma means the sum divided by n. Now for the group data, it is sigma of f, the frequency multiplied by the midpoint of the classes divided by n, where n will be the total number of the total of the frequencies. Just to explain this idea, let's solve this example. I need to find the mean first. In the frequency distribution, we are given the classes or class boundaries, frequencies are there. We need to find the midpoint for each class. So the midpoint for the first one, it is 10.5 plus 5.5 is 16, divided by 2 is 8. Remember that the midpoint, xm, will be the lower limit or boundary plus upper boundary divided by 2. That will be 5.5 plus 10.5 divided by 2, which is equal to 8. So this is the midpoint, or this is the first one. We call it x1, not xm. So it is 8. Second one can do the same thing, or we can notice that the class width is equal to 5. So either I will sum the lower limit or the lower boundary plus the upper boundary divided by 2 for each one, or just find the first one and then add class width in each step. So we notice that the class width is equal to 5. So if we add 5, I will have 13, plus 5 is 18, plus 5 is 23, plus 5 is 28, plus 5 is 33, and plus 5 is 38. Now I need to find f multiplied by xm, frequency multiplied by the midpoint. The first one, multiply these two. 1 times 8 is 8. 2 times 13 is 26. 3 times 18 is 54. 5 times 23 is 150. 4 times 28, that will be 112. 3 times 33 is 99. and 2 times 38 is 76. Now I need to find the sigma. Add all of these. We take this out. Now sigma of fxm is equal to, just find the total for all of these. I'll have 8 plus 26 plus 54 plus 115 plus 112 plus 99 plus 76. That is 490. So the mean x bar will be the sum of this one, that is 490 divided by n. N is the total of the frequencies. I have 3, 6, 11, 15, and n is equal to 20. Just add the frequencies and we will get 20. So it is 490 divided by 20. That will be 49 divided by 2. It is 24.5. So the mean is 24.5. This is the idea of finding the mean for grouped data. First step, we have to find the midpoint of the classes. Then we multiply the frequencies with the midpoint, add the total or the results for the multiplication, divided by the total number of the frequencies, or just the total of the values of the frequencies, which is in this case n equal to 20. So this is the mean for grouped data. Now for the mode. For the mode, we have the formula. For group data, we are using the formula of the mode, which is this one. It is L plus delta 1 divided by delta 1 plus delta 2 multiplied by W or the class width. Delta 1 is the model frequency minus F1. Delta 2 model class or model frequency minus F2. It should be frequency. See, what do we mean by the model frequency? For the mode, I'm going to just focus on the class boundaries and frequencies. Again, it is L plus delta 1 divided by delta 1 plus delta 2 multiplied by omega. Now delta 1, or you see the model classes. Model class means the class with the highest frequency. See, what is the highest frequency is equal to 5. We are looking for the highest frequency, which is equal to 5. So the model class is not equal, you say it is 20.5 to 25.5. Now from the model class, I will take the lower boundary. So L is the lower boundary, it is 20.5. This is L, the lower boundary of the model class. Now the model frequency is equal to 5. Now this will give me delta 1, it is model frequency minus F1. F1 is the one up above the model frequency. So this is F1. This will be F2. F1 is the frequency just above the model frequency, and F2 is the one just under the model frequency. So I have F1 and F2. This will give me delta 1 equal to 5 minus 3, which is equal to 2. Delta 2 is 5 minus 4, which is equal to 1. And we know that the W, the class width, is equal to 5. This is class width. So the mode for this one will be, using the formula, it is 20.5 plus delta 1 is 2, divided by delta 1 plus delta 2, multiplied by class width, which is equal to 5. So this is 20.5 plus 10 divided by 3, which is equal to, approximation for this one, 10 divided by 3 plus 20.5, which is almost 23.8. So this is the mode using the formula. It is 23.83. So again, to find the mode for grouped data, we are speaking about the group data, not about any group. We have this formula, it is L, lower boundary for the model class. Model class means the class with the highest frequency. We are taking the lower boundary, and we found delta 1, which is the difference between the model class and the frequency just above that one, and delta 2, which is the difference between the model frequency and the one under the model class or model frequency. Then we apply the formula L plus delta 1 over delta 1 plus delta 2 multiplied by the class width, which is in our case is equal to 5. The value is equal to 5 in our case. There is another method to find the mode, or we can approximate the mode using the graph. Try to find the mode using graph. And for the mode, we are using the histogram. To find the mode, we need to use the histogram. So to find the mode using the graph, let's construct the histogram. Remember that for the horizontal, we put the class boundaries. This is and this one will be the frequencies. Now class boundaries start from 5.5, then 10.5, 15.5, 20.5, 25.5, and 30.5, 35.5, 40.5, and 45.5. The last one is 40.5. Now into 40.5. 40.5. Frequencies from 1 to 5. Let's say between this is 1, 2, 3, 4, 5. Now let's graph the bars for the histogram. The first one is 1. So this is 1. Second one is 2. Third one, 3. Fourth one, it is 5. Then next one is 4. Then you have a 3 and 2. Now to find the mode using this histogram, we are going to the highest one. This is 1. This is the highest bar, and we will do cross from the right corner to the left corner of the one before, from left corner to the one after. Now the intersection point will give me approximation of the mode. So the mode will be this one. So again, just graph cross between the corners of the highest mode and the two besides, to the left and to the right, and see where the intersecting point. Then draw a vertical line from the intersecting point to the horizontal axis. This point is the mode. So the mode is approximated equal to like 24. And this is approximation to find the mode using the graph. Using the formula we found, it is equal to 23.83. And this is just approximation to say that the mode is close to number 24. So this is the idea of finding the mode using the graph. Again, this part, we found the mean of the group data, which is sigma of f multiplied by xm, the midpoint, divided by the total value of, or the total of the frequencies. Then we found the mode using the formula, which is L plus delta 1 divided by delta 1 plus delta 2 multiplied by the class width, W. And we found the mode using the graph, or using the histogram, which is construct the frequency, then do just a cross line between the corners of the highest frequency or the highest bar with the two besides, and looking for the intersection point. Coming down to the x-axis, and that will be the approximation of the mode.